Nuclear accident, ядерная авария. Nuclear or radiation accident is defined by International Atomic Energy Agency, IAEA, as an event that has led to significant consequences to people, environment, or facility. Examples may include lethal effects to individuals, release of radioactive isotopes to environment, or reactor core melt. International Nuclear Event Scale, международная шкала ядерных событий. The International Nuclear and Radiological Event Scale was introduced in 1990 by International Atomic Energy Agency in order to ensure prompt communication of significant safety information in case of nuclear accidents. A number of criteria and indicators are defined to assure coherent reporting by different official authorities. There are 7 non-zero levels on the scale, 3 incident levels and 4 accident levels. There is also a 0 level on the scale. Defense in depth, глубоко эшелонированная защита. Defense in depth is an approach that creates multiple independent and redundant layers of protection and response to failures, accidents, and fires. For example, defense in depth means that if one fire suppression system fails, there is another to back it up. The idea is that no single layer, no matter how safe and robust it is exclusively relied upon. The defense in depth systems are designed to compensate for human and mechanical failures that may occur on the facility. Emergency core cooling system – система аварийного охлаждения реактора. The term emergency core cooling system is used to describe a collection of systems and facilities designed to ensure that the reactor core remains cooled in the event of an accident. The primary aim of these systems is to ensure that the reactor core do not become uncovered in the case of loss of coolant, and parts of the reactor, particularly containment, do not become pressurized to the extent when it gives the pathway to the radioactivity to reach the environment. Inherent safety – естественная безопасность. Inherent safety refers to the achievement of safety through the exclusion or elimination of inherent hazards through fundamental conceptual design choices for nuclear power plant. Potential inherent hazards for nuclear power plant may include radioactive fission products and their associated decay heat, excess reactivity and its association of power excursions, releases of energy due to high temperatures, high pressures, and chemical processes. Core catcher – ловушка расплава активной зоны. A core catcher is a device provided to catch molten core material, corium, of nuclear reactor in case of a nuclear meltdown and prevent it from escaping containment building. In some documents, core catcher is also known as a melt trap. Ionizing radiation, ионизирующее излучение. According to World Health Organization, ionizing radiation is a type of energy released by atoms traveling in the form of electromagnetic waves, for example, X-rays or gamma, or particles, neutrons, alpha or beta radiation. Ionizing radiation is able to break chemical bonds in the matter through which it passes. Effective dose, эффективная доза. When we talk about the radiation dose, we normally talk about effective dose. Effective dose takes into account the type of radiation and the nature of organ or tissue being irradiated and enables summation of all doses received through the body or tissue due to different organs and types and levels of radiation, both external and internal, to produce overall calculated effective dose. Effective dose is measured in sieverts. ALARA – разумно достижимый низкий уровень. ALARA is a safety principle based on acronym as low as reasonably achievable. It usually refers to chemical and radiation exposure levels. In an ideal world, one could reduce his exposure to hazardous materials to zero. In reality, it's not always possible. In order to reduce this risk from increasing is to keep his exposure to as low as reasonably achievable. Beyond Design Basis Accident – запроектная авария. Beyond Design Basis Accident, or BDBA, is a technical way to discuss accident sequences that are possible, but they were not considered fully during the design process as they were judged too unlikely. In this sense, these sequences are considered beyond the scope of design-based accident that nuclear facility must be designed with and built to withstand. As regulation process tries to be as thorough as possible, these sequences are studied thoroughly to understand the capability of a design